So today's lesson is on page 10, lesson 2, intercepts and slopes. So we're going to start a little bit of a review of the coordinate plane. This is our coordinate plane. It has an x-axis, it has a y-axis, and it has 4 quadrants, but you may not know the names of them. Quadrant 1, 2, 3, and 4. And they make the shape of a little bit of a C, the C shape, in case you're wondering what order they get numbered in. So we are going to plot the following points on the grid and then state which quadrant or axis they are located on. So the first one I'm going to plot is -2, 3. So -2, you always have to read the x coordinate first and then the y coordinate. So -2, we read that on the x coordinate and then we go 3, 1, 2, 3. So we're going to plot that point right here, and that's going to be my point A. The second one, 2, 0. So we're going to read the x-axis first and then 0, which is right here. So there's B. C is -3, -4. So you're going to plot that here. And then D is 0, -3. So 0 is here on the x-axis, and then we go down by 3. So that one lives right on the y-axis. And then 4, 4 is up here. There's E. And then -3, -1 is going to be down here. That's F. So if you are in the first quadrant, then you are going to have a positive x coordinate, and you're also going to have a positive y coordinate. If you live in quadrant 2, which is over here, you're going to have a negative x coordinate, and you're going to have a positive y coordinate. Okay. If you live in quadrant 3, then both of your x and your y are going to be negative, like this point here, C, -3, -4. So you're going to have negative x and negative y. And if you live in this quadrant, you're going to have a positive x, you're going to have a negative y. You're expected to know that. All the points that live on the x-axis, let's see, we have 1. That was 2, 0. This is B. You'll notice that all the points on the x-axis have 0 as their y coordinate. Whereas all the points on the x-axis have 0, or the y-axis have 0 as their x coordinate. Okay. So we're going to move on to this idea of what the intercepts are. So here's a graph. It's on the coordinate plane, but the graph is actually the red arrow. So the red line is the graph, and this red line is the other graph. So an intercept is the point where a graph crosses an axis. And you can see that this red graph crosses the axis here, as well as here. We are going to determine the coordinates of the x and y intercepts of the graph above. So we can actually read it right off of here. If we read the ticks 1, 2, 3, 4, 5, so the coordinates of this point are 5, 0. And the coordinates of this point here, this intercept, are -5. Sorry, not -5. 0, -5, because you have to read the x coordinate first. 0, -5. Be really careful. If you mess those up or switch them, then you're wrong. So in graph 1, the x-intercept is the place where it touches the x-axis, and that happens to be 5, 0. If you look at the place where it touches the y-axis, then it's 0, -5. If you look at graph number 2, then it touches the x-axis here at -2, 0. So the x-intercept is -2, 0. But the y-intercept, as you can see, this red graph is going to go forever upwards and forever downwards, but because it's a vertical line, it's never going to touch the y-axis. So this y-intercept does not exist in this case. Now, if we check these coordinates with what we said earlier that all points on the x-axis have 0 as the y-coordinate. We said that right up here. And as we can see, that is true. So we know that we haven't messed this up. Whereas the y-intercepts, or points that live on the y-axis, have 0 as their x-coordinate. So that's all consistent. That seems good. So we are now on page 11, check your understanding 2A, and it's asking us to find the x-intercept of graph A. So we are going to look at the x-axis and we're going to figure out where graph A actually hits over here. Now, some people would just put 3, but I'm telling you that it's much better habit to state both coordinates. It shows that you understand that this is 3, 0 and not 0, 3. And then your y-intercept is here, and some people would just call that -5, but it's better if you state it as 0, -5, shows that you understand what the coordinates are. The marked point that was originally in the notes is here. So the dot that they put there, that's going to be 6, 5. And which quadrant does the line run through? Well, sometimes I have to relabel this, otherwise I can't remember. 1, 2, 3, 4. Okay. So the quadrant that this line A runs through is this one here, quadrant 1. It also runs a little bit through quadrant 4 and also a bit through quadrant 3. But you can see even if you extend this line forever, it's never going to touch quadrant 2. So we're going to put 1, 3, and 4. And those are the quadrants. So what I'm going to get the students to do at this point is to try B. Can you just put your responses like as a single line right here in the chat box? And then if you can do C after that, that would be good too. So if we go to graph B, we can see that the x-intercept is going to be 4, 0. And then the y-intercept is going to be 0, 2. The marked point is -2, 3. And some students got this wrong because they put 3, -2. Make sure to read the x first and then the y. And then the quadrants that it runs through are this one, 1, 2, and 4. Okay. And I'll leave the last one for you to do down here because the answers are literally right there, and you can check that yourself. But I want to move on to this idea of how to read a slope from a graph. So you might have heard before that a slope is like the vertical change over the horizontal change, or you might have heard this idea of rise over run. So many times we say m is the slope, and we calculate it by rise over run. So what does that mean? So here's a line, this bold one right here, and maybe they even extended the line because it goes off forever in this direction, and it goes off forever in this direction. But the slope is going to be the same no matter where on the line you read it from, because it's always the same steepness no matter where you read. So if I'm going from point A to point B, you can see that the rise, if I'm trying to walk from A to B, I'm going to have to walk downwards and then to the right. So the rise is actually 1, 2, 3. So I have a rise of -3 because I'm walking downwards. And then a run of 1, 2, 3, 4, 5, 6. And because I'm walking to the right, that would be a positive run. Okay, positive 6. But what if I was to walk from B to A? Then I would be walking upwards. I could have a rise of positive 3. 1, 2, 3. And then I could have a run of -6. But what you can see from this is that when you calculate the slope, rise over run, I can calculate it as -3 over 6, which you must reduce to -1/2. Or you can calculate it with +3, rise over run, over -6, which also simplifies to -1/2. So whether you're walking from A to B or B to A, you're going to get the same final answer, even though your rise might be negative and your run positive, or vice versa. In the second example, we can mark this off again. Let's say that we started here, and this is point A, and this is point B, and we'll just walk along the dotted line. So we're going to walk upwards by 3, so we can say that our rise was +3, and our run was 1, 2, 3, 4, 5, 6. So our run was +6. So then our slope, which is usually represented by m, is going to be the rise over the run, or 3 over 6, which you must reduce to 1/2, and this time it's actually positive. If you decide to go the other way and walk from B to A, then your rise, you're going to be walking downwards, you're going to rise by -3, and then you're going to run to the left. So you're going to run -6. And if you decide to calculate your slope that way, you will have -3 over -6, which is also 1/2. Note to everybody, I never want to see you enter into one of my D2L quizzes a negative over a negative. You know you didn't reduce that properly. Okay, it has to be reduced to positive right there. So this has a slope of positive 1/2, that red piece, and then the blue one has a slope of negative 1/2 when we calculate it rise over run. Okay, let's just do one more example on the next page. And we'll just calculate the rise over run of this line on the left here. So they told us the coordinates of this point, which is -2, -1, and they want us to rise to here. So if you are going from this point to this point, and you're starting at -1, let's follow this red line to calculate the rise. 1, 2, 3, 4 units. So the rise is 4, and the run is going to be 1, 2, 3, 4, 5, 6 units. It's very hard to see when there's no grid. Now let's just make sure we didn't put the wrong sign. We did rise upwards and run to the right, didn't we? Yes, so they are both positive. So when you are calculating your slope, it's going to be 4 over 6. You leave it like that, it's wrong. You have to put 2 over 3. The reduced fraction is always correct. So one thing that you can use as a shortcut in knowing whether your slope is positive or negative is if you have a slope that rises up to the right, like if you start on the left-hand side and you're climbing your mountain to the right, it's going to be a positive slope for sure. If you are going left to right and you are falling down the mountain, you are going to have a negative slope for sure. But what happens if you have a horizontal line? Well, this is actually a 0 slope. And the way I can explain that is that if you go from this point A to this point B and you're looking at your rise, it's actually nothing. There's nothing to rise to. So if you have a rise of 0, it doesn't matter what your run is. Could be anything, but 0 over anything is still 0. And that's why a horizontal line is going to have a 0 slope. Where things get much more abstract is what's going on with this undefined slope, this vertical line. So if you start here and you are rising up here, you could count a certain number of units. Maybe it's like 4 units. So maybe your rise is 4, let's just say for the sake of argument. But then what's your run? Are you moving from left to right at all? No. So your run is actually 0. Because there's no left or right movement to get from A to B. So when we calculate a rise over our run, you're going 4 divided by 0, which you know causes everything in math to break down. This doesn't work. Okay, so what this actually means is that a vertical slope is what we call an undefined slope. Some people would call it infinity slope, but in this course we call it undefined slope. So when we talk about oblique lines are like this or like this. They're diagonal lines. They either have a positive or a negative slope. Horizontal lines have a rise of 0 and a run of pretty much anything you want, but doesn't matter what it is because the slope is going to still be 0. If you have a vertical line, you're going to have a rise of pretty much anything, but then you're going to have a run of 0, and you can't divide by 0, so the slope will be undefined or infinity. I suppose I would accept that as well. Okay, so let's do a little bit of an example. We have slope of A, B. So walking from A to B, we're going to rise by 1. Okay, we start here. 1, 2, 3, 4, 5, 6, 7 boxes. So we're going to rise by 7 and we're going to run by 3. That doesn't reduce. Now I'm just going to double check to make sure that I have the correct sign because that's where I always mess it up. Is it really positive? Well, am I climbing a mountain from left to right? I am. So this is a positive slope and I'm just going to leave it without a sign. The slope of CD, if I'm running the rise, I'm rising by -2 and I'm running by 1, 2, 3, 4, 5, 6. And I can't leave it like that, -1/3. And if you're not sure if you got the correct sign, let's see, from left to right, am I falling down the mountain? I am. Should be negative. The slope of EF is, of course, 0 because it's a horizontal line. And then the slope of GH would be undefined. A slope is the steepness of a graph. So in this example, I'm going to show you how to draw something or draw a line if we know the slope. So we have a couple clues about this. It passes through -7, -2. So I'm going to plot that point 2 first, -7, -2, right here. And it has a slope of 5/4, which means that I have a rise of 5 and a run of 4. So I'm going to rise by 5. I'm going to walk up by 5. 1, 2, 3, 4, 5. Let me just try that again. 1, 2, 3, 4, 5. And then I'm going to run by 4. 1, 2, 3, 4. And then I'm going to plot another dot. Usually 2 dots are enough to plot a line, but if you want to plot accurately, you should do it again. Rise by 5. 1, 2, 3, 4, 5. Run by 4. 1, 2, 3, 4. Okay. And now that I have 3 dots, I feel much more confident drawing my line like this. When you draw a line, I would expect that you extend the line to the edge of the graph and you put arrows on the end to indicate that it goes on infinitely. And this is A. Okay. If you are doing example 2, let's do that again. So we're going to plot the point that they told us to plot, -5, 6. So we're starting with this one. And they want us to do a slope of -2. Wait a second, I'm supposed to have a rise and a run, but I don't have a run. I just have a rise. So keep in mind this one down here, if it has a slope of -2, -2/1. So you have 2 options. You can rise by -2 and you can run by 1, or if you want, you can rise by 2 and you can run by -1. Either way, that's going to work, okay? But because I'm already pretty high on the graph, I'm going to try and rise in a negative direction because I want to move downwards. So -2 and then run by 1, -2, run by 1, -2, run by 1. And the more dots you point, or the more plots you point, the more accurate your graph is going to be in the end. Once you have enough, then you can just draw your line. That's not a very good line. Draw it like this. And I will extend my line to the edge of the graph. And then I will put arrows on the end. And this is going to be my graph B. The third example, we're passing through 5, 4. 5, 4 is going to be up here. And it says it has a slope of 0. So I already know what a slope of 0 means. It means it's a horizontal line. So I can right away just plot it like so. And I can say that that is C. And this one actually didn't give me a point. So I guess I can't really do that one. But it would have been a vertical line. Example number 3. Arrange the slopes from flattest to steepest. Okay, I want to show you what a steep line will look like. A steep line is like this. It has a very big rise, and it has a very small run. And if you have a shallow line, it's going to look like this. It has a very small rise, and it has a very long run. These ones are going to have a very large slope. M is big. And the reason it's big is because the rise is on the top. So for example, if you have a rise of 10 and a run of 1, your M is going to be 10. If you have a rise of 1 and a run of 10, your M is going to be this tiny little fraction. So the bigger the slope, the steeper the line. So really all they're asking you to do is put these in order from the biggest magnitude to the smallest magnitude. So if you wanted to use a calculator to help you determine which of these slopes or what the decimals are, that might help you with the fractions if they get a little tricky. But you know that this is 1, that's about 0.5, this one's about 0.75, and this one's about 0.67. So really, the flattest slope is going to be the 1/2. That's the smallest slope, followed by the 2/3, followed by the 3/4, followed by 1. Does it matter if there's a negative? No, because a negative will affect the direction of the slope. It will not affect the steepness. So in the chat box, can you please put these in order from the flattest one first and then the steepest one last? So most of the students were able to do this, and they said that the flattest one was going to be 1/2, followed by -2/3, followed by 3/2, followed by -2. And the negative doesn't matter. It doesn't affect the steepness. So example 4 says determine the slope of a line with this intercept and this intercept. So it gives us an x-intercept of 3. So let's go ahead and plot that. X-intercept of 3, because here's the x-axis and here's the y. And then a y-intercept of 5. 1, 2, 3, 4, 5. So this is our line. If we connect these dots, it will give us the line that it's talking about, this one here. Okay, 2 dots are enough to draw a line if you have a ruler. But I'm just going to extend this like this. So here's the line. We did sketch it. And then they want us to determine the slope. So the slope is determined from 2 convenient points, any 2 convenient points. So because I have this rise and this run, I can say that the rise is going to be from here to there. I believe that's a rise of -5 and a run of +3. So down by 5 over by 3. So then I can determine that the slope is -5 over 3, and that doesn't reduce. I am going to do this first example because I think it confuses kids with the wording. For the line shown, find the slopes of A, B, etc., etc., etc. So basically what it's saying is if you find the slope between A and B, so we do the rise over the run, so we have a rise of 2, so between A, B. We have a rise of 2 and we have a run of 3. So this is our slope. But what if we go between, say, A and C? Well, if you run between A and C, then the rise is actually 1, 2, 3, 4. And then the run is 1, 2, 3, 4, 5, 6. But that reduces to 2 over 3. So what the point that they're trying to show you is that no matter which 2 points you pick, if they're all in the same line, wherever you measure from, it's going to be the same slope. The steepness of the line doesn't change just because you're writing the slide here or you're writing the slide here. It's the same steepness. That's what it's trying to show you. A hint for this question, because these lines do not have endpoints that end on a nice number. Like they end in the middle of a square, for example. So you don't want to use those endpoints to calculate the slope. What you want to do is you want to choose points that lie conveniently exactly on the grid. And those are the points that you want to calculate the slope. So part of the skill is being able to read the graph and choose points that are going to allow you to calculate that slope. It doesn't matter which points you choose, but you want to choose ones that lie conveniently right on the grid. And that's your hint for that. So